Hello, everyone. I'm Zhao Chuan. Welcome to the PNSO Dinosaur Museum scientific art exhibition of Aubrey the Torosaurus and the suborder Ceratopsia. Ceratopsians are very impressive among all dinosaurs. At first glance, you may feel such animals looked very much like rhinoceros, with a heavy trunk, a big head, strong forelimbs, and a not very long tail. In addition, what is most striking is that they had various horns, but not all ceratopsians had a horn on the face. One basic feature of ceratopsians was that they had a similar skeletal structure. Besides, all ceratopsians possessed a parrot-like mouth. The most primitive ceratopsians such as Ainiosaurus and Psittacosaurus, that walked on two legs, didn't have a large size as the later ceratopsids. But ceratopsids, such as Triceratops and Torosaurus, both had such a feature, that is, the parrot-like mouth. Most members from the suborder Ceratopsia had a big or small frill on their head. One lineage of the suborder Ceratopsia is the family Ceratopsidae, which refers to the dinosaurs with a huge body and long horns. Triceratops, Protoceratops, Styracosaurus, and Pachyrhinosaurus that were commonly seen all belonged to ceratopsid dinosaurs. The family Ceratopsidae is a subdivision of the suborder Ceratopsia. Torosaurus, today's protagonist, is a genus of ceratopsid dinosaur. Before we introduce Torosaurus, let's first know something about the suborder Ceratopsia. One representative of ceratopsian was Psittacosaurus, as we can see from this picture. Psittacosaurus is a genus of ceratopsian dinosaur, whose fossils are best preserved, as we have known so far. It didn't have a large size. The bigger one could grow up to 1 meter, and the smaller, just as large as kittens and puppies, could be around 60 centimeters in length. It had many other features, for example, relatively developed cheekbones. The cheekbones of this Psittacosaurus sinensis had developed into jugal horns, which looked like two long spikes. Relatively developed jugal horns were commonly seen among late ceratopsids. Protoceratops in the family Ceratopsidae had particularly developed jugal horns too. Protoceratops actually had only 3 horns on its face, but as it had well-developed jugal horns, in the early years, people mistakenly believed that they were 2 horns. Because a lot of fossils of Psittacosaurus are collected so far, we have a deep understanding of it. First of all, it walked on 2 legs. In early days, it was described sometimes as a quadruped and sometimes a biped. But nowadays, we believe that it usually walked on 2 legs. As it had short forelimbs and long hind limbs, and there are sharp claws on its forelimbs in some specimens, its forelimbs were not suitable for walking. A lot of skin fossils of Psittacosaurus have been well preserved, so we know what its skin was like. There were very small scales on its body, and between them, there were many large scales. These scales spread in rows and were distributed regularly on both sides of its trunk. They were densely packed on its shoulders. A cluster of feathers were found on the tail of a well-preserved specimen. These long feathers with a simple hollow structure grew along the dorsal part of the tail. In the early years, people believed that they were fossils of aquatic weed overlapped on the dinosaur. Later, after observing them with the electron microscope, it was found that they indeed have biological features of feathers and denied the saying that they were aquatic weed. What's more, similar feathers were also found on specimens of some ornithischians such as Ainiosaurus. Therefore, we feel more certain that it is a structure of feathers. There were many other features about the skin of Psittacosaurus. Between its thigh and tail, there was a layer of skin, which looked like a wing membrane. Such skin allows us know that many dinosaurs might share the similar feature. In the early years, when we restored dinosaurs, we often separated their thighs from the trunk. However, nowadays, we believe that many dinosaurs might have the skin connecting their thighs and the trunk, which limited the motion range of their thighs to a certain extent, and made its body steadier. It means that when dinosaurs walked, they might often bend their knees and ankles. They didn't rely on the joints at the root of their thighs, so their thighs could only move in a small range. Apart from Psittacosaurus, such a feature was also found on specimens of some theropods, such as Ornithmimus. On a Ornithmimus specimen, the skin in front of the thighs was found connecting the sides of its belly, thus overturning our previous idea about dinosaur restoration. In addition, pigments were found in the skin of Psittacosaurus. The best preserved specimen of Psittacosaurus is from Liaoning, but we haven't compared its skeletons in a deeper way, so currently it is still unknown whether it was a new species or P. lugicunensis commonly seen in Liaoning. Intact pigment fossils were kept on its body. We know that its whole body looked brown, and its face was relatively darker, nearly black. Large scales on both sides of its body, especially those on its shoulders, all looked dark. Generally, the scales on its shoulders formed many spots. Those are some features of the anatomical structure of the body of Psittacosaurus. In recent years, the preserved cloaca fossils of a dinosaur was discovered for the first time. We have learned about the specific shape of dinosaurs' cloaca. On both sides of the cloaca there were glands. Perhaps, like many modern animals, dinosaurs would leave smell in their own territory, which proves that they might have a keen sense of smell. In addition to the observation of the body surface of Psittacosaurus, including its skin, we have known something about its behaviors. Many specimens of Psittacosaurus that have been well preserved are about an adult individual leading a group of young individuals. The number of these young individuals was large. Some could reach over 30. They didn't seem to be the children of the same family. Perhaps, like ostriches today, a few of them formed a family group, with all the young being taken care of by the adults by turns, in a way of breeding as children are taken care of in kindergartens. One interesting thing is that a lot of specimens with young dinosaurs were kept chaotically. There were young dinosaurs above and below the skeleton of the adults. They were surrounding the dinosaur. So some people speculated that Psittacosaurus might be a genus of burrowing animals. It might live in a burrow dug. Generally, if the burrow was flooded and dinosaurs died inside, because of the water swirl, such a state of preservation was formed. That is a guess we have made so far about Psittacosaurus. But Psittacosaurus looked like other ornithischians, that walked on two legs, had a small size, ran flexibly, and was in primitive state without a frill on the head. It looked very different from ceratopsids we will introduce later. Within the suborder Ceratopsia, there were a group of dinosaurs, which were very close to ceratopsids. For example, the Protoceratops we are going to introduce next. It was a genus of Asian ceratopsian dinosaurs unique to China and Mongolia. It didn't have a large size, almost the same as a pig. The features of Protoceratops are that it had a big head, a parrot-like mouth, and a thick and strong lower jaw. Like many later ceratopsids, it had a huge head frill. Now we know that Protoceratops was not exactly the ancestor of later ceratopsids. It had no direct biological relationship with them. It could be considered as an ancestor type. In other words, Protoceratops didn't directly evolve into ceratopsids. Instead, the real ancestor of ceratopsids produced a collateral branch, which evolved into Protoceratops. The relationship between them is a bit like that between humans and monkeys. Humans are not descended from monkeys, but share a common ancestor with monkeys. Protoceratops was a dinosaur we know well because of its abundant fossils. Its remains were first discovered by Andrews, the curator of the American Museum of Natural History, and the team he led during an expedition in Mongolia at the time. When they discovered the remains of Protoceratops, they found a clutch of eggs too, on which there were remains of another well-known dinosaur, Oviraptor. They found that clutch of eggs near the place where the remains of Protoceratops were discovered, so they thought the eggs belonged to Protoceratops. At the time, it was believed that Oviraptor came to steal the eggs of Protoceratops. The logic was like that, thus causing an unjust case which lasted for over 100 years. Now we know the eggs actually belonged to Oviraptor, which was not the thief. So far, no egg of Protoceratops has been found, but we have found specimens of this species of all stages from embryo through to adult. And we have witnessed the whole growth process of Protoceratops. Let's first talk about its growth process. Adult Protoceratops had a very large frill on its head. But in childhood, It had no frill but a protuberance on its head, looking like a young Psittacosaurus. As it got older, the frill on its head grew long and thin, backward little by little. When it was about to become an adult, the frill suddenly grew horizontally, becoming a large round one. The frill was hollow inside, and there were 2 openings in it, which made an empty show of strength and had no actual protective function. And the frill was hollow, it was not very sturdy. When reconstructing Protoceratops, we draw eye-shaped spots on the frill as the picture shows. Those eye-shaped spots might frighten the enemy, but it was more likely to show off. Then let's talk about its reproduction mode and its eggs. So far, no specific egg of Protoceratops has been found, but we have found its embryo. A relatively new study believes that the eggs of Protoceratops might be different from other dinosaurs. They might be soft-shelled ones, just like those of lizards and snakes. We know that dinosaur eggs were like bird eggs, whose surface is a hard calcified shell, but the eggs of Protoceratops might have not been so heavily calcified, so they might be soft-shell eggs. We have found many eggs in the embryonic stage, but the eggshells have not been kept, which is something unusual. In the area in Mongolia, where the remains of Protoceratops were discovered, many other dinosaur eggs were discovered too, especially the eggs of Oviraptor. Usually, the shells of Oviraptor eggs were easily preserved, but that was not the case for Protoceratops. Logically, the calcified eggshells were more easy to be preserved than the embryo inside, but a situation like that has not been found among so many specimens of Protoceratops. Scientists carefully observed the specimens with the embryo discovered and found that around it there was a faint circle, which showed the shape of the egg. Therefore, its eggshells might rot more easily and the eggs were perhaps soft-shell ones. Of course, that is just speculation. In addition, there is a famous specimen called Fighting Dinosaurs, which probably preserves a Protoceratops in battle against a velociraptor. The fossil shows that the Protoceratops bit a hand of the velociraptor, while the latter used the claw of its hind foot to reach the throat of the Protoceratops. The state of a fierce combat may have been preserved. The surrounding sediments where the fossils preserved are with sandstone, so they presumably fought near a dune. They might have missed a step and got stuck in the quicksand, or a dune near them collapsed and buried them, which caused their death. Of course, that is just speculation too. Some people hold an opposite opinion. They believe that this specimen was formed by accident, perhaps because quicksand or water brought the 2 animals that had died nearby together. Whether this specimen shows a combat or not, Protoceratops and Velociraptor did live in the same place during the same period. These 2 animals were likely to be competitors. They had a similar size. Neither of them was tall. Like the relationship between wolves and pigs, probably they often fought. That is for sure. This animal we now see is called Ainiosaurus. It was a typical ceratopsid dinosaur. It had a frill with various decorations on its head. Ceratopsians, for example, Protoceratops, generally had a bare frill with smooth surroundings. Like most ceratopsids, Ainiosaurus had some spike-shaped structures called processes on its frill edge. Ainiosaurus was a typical dinosaur with developed processes. Generally, the processes were small, but the 2 at the top of its head became very long horns, which looked like a rabbit's ears. There was a on its nose too, but the shape of this horn was different from that of most ceratopsians. Generally, the horn of most ceratopsians was straight, but that of Ainiosaurus bent downward, forming a hook. The Ceratopsidae is classified as a family within the suborder Ceratopsia. The family Ceratopsidae is divided into 2 subfamilies, Centrosaurini and Chasmosaurini. Ainiosaurus was a typical centrosaurine. Generally there was no brow horn above the eyes of centrosaurines, but there were exceptions. Ainiosaurus was not very tall, with its body length at only about 5 meters, but it had a heavy body, which looked like a rhinoceros or buffalo. Fossils of Ainiosaurus show that such dinosaurs usually lived in groups, which is a shared characteristic of ceratopsians. Generally, Psittacosaurus, Protoceratops, and Ainiosaurus all appeared in large groups. Individuals looked clumsy and they had very heavy weapons, so living in groups could better protect themselves. although carnivorous dinosaurs ate ceratopsians too, but they were more inclined to prey on animals like hadrosaurs they could catch easily. Ainiosaurus was an unusual evolutionary branch of dinosaurs among ceratopsians. First of all, from its nasal horn, we can see it was unlike many typical ceratopsians. In addition to Ainiosaurus, there were some more peculiar centrosaurines, such as Pachyrhinosaurus we'll talk about next. This drawing shows a Pachyrhinosaurus fighting a Ainiosaurus. Ainiosaurus is a tyrannosaurid that lived very north, from Canada, and Pachyrhinosaurus also came from very north. Some people think they might have feathers on them. Tyrannosaurids such as Ainiosaurus might have grown some feathers to keep warm, but Pachyrhinosaurus probably did not. Some previously found skin of Pachyrhinosaurus shows that it had exposed scales, no traces of feathers on the body, and it did have the features to grow feathers. Many previously discovered skin fossils of ceratopsians show that their skins were very thick and scaled, which could keep them warm. When the weather turned cold, they might migrate on a large scale to avoid cold areas, which was a habit of Pachyrhinosaurus. And Pachyrhinosaurus had a feature that it had a very thick bone on its nose. When alive, the bone might be covered by some keratins, making it stronger, a bit like an electric iron. Therefore, Pachyrhinosaurus might be different from other dinosaurs when it came to defending or fighting its peers. Other ceratopsians might lock their horns and wrestled or attack the enemies with their horns, while Pachyrhinosaurus might be more adept at ramming enemies with their head. At present, 3 species of Pachyrhinosaurus have been identified, and the most famous one is Pachyrhinosaurus lacusti in the picture. In addition to the thick knob on the nose, another feature that Pachyrhinosaurus lacusti possessed was 3 small spikes on the top of the head frill, which might be used to attack enemies. It might use the head frill as a weapon. Although its head frill was hollow and unlikely to be used as a shield, it still played a small role and protected the neck somewhat. But because of the spikes, it could attack other dinosaurs with its head voluntarily, which makes it somewhat different from other ceratopsians. Previously, it was thought that Pachyrhinosaurus had no nasal horns, and its so-called thick nose was a lump that developed independently of its nose. Now we generally believe that Pachyrhinosaurus might be related to the previously introduced Ainiosaurus. The nasal horn of Ainiosaurus were curved downward, and the nose of Pachyrhinosaurus was likely to be the next state of Ainiosaurus. Pachyrhinosaurus lived in a later period than Ainiosaurus, and it might be evolved. Ainiosaurus, the curved part of Ainiosaurus horn, gradually thickened, forming the lump. We can see among the several small spikes at the front end of Pachyrhinosaurus' thick nose, there was generally a relatively large one, which might be the vestigial front end of the previously downward horn. This might be the origin of the unique appearance of Pachyrhinosaurus. In addition to Pachyrhinosaurus, there was another very important dinosaur that also lived in Canada, that is, Centrosaurus. Centrosaurus was the typical representative of centrosaurines, so they were named after it. A feature of Centrosaurus that all the centrosaurines shared was that they had relatively small head frills with some developed ornaments. Its nasal horn was relatively developed, and brow horns were small, while some had no brow horns. Generally, at this area, there was no brow horn, but some specimens show that some had to blunt pyramid-like hornlets. There are many fossils of Centrosaurus, which have been found in the Dinosaur Park Formation in Canada. Thousands of their fossils have been found in this area. They were animals that walked in groups, and probably a large group of them drowned in the river while they were trying to cross it, leaving such a spectacular bone bed. Due to the large number of individuals, by comparison, we found that each of them looked basically different, and the directions of their nasal horns were very different, too. Some nasal horns were curved forward, some downward like Ainiosaurus, some curved backward, some straight, some long and some short. As for the brow horns above the eyes, some were shorter, some not very long, like a small pyramid, and some didn't have any. In the past, Centrosaurus were divided into 2 species. In addition to type Centrosaurus, there was another species called Centrosaurus bringmani, which had two brow horns growing to both sides above their eyes. Generally, on top of the head frills of Centrosaurus, there were some additional ornaments. For example, the first pair curved inward, the second pair hung downward, the others were larger and then gradually got smaller. Instead of the two larger outward horns, Centrosaurus bringmani had two small broccoli-like spiny balls. However, through research over the years, people believe that Centrosaurus bringmani might not belong to Centrosaurus, and now it's generally identified as a new genus called Pachyrhinosaurus bringmani. The next one is called Spinops, which was relatively closely related to Centrosaurus. Many parts of its body were very similar to those of Centrosaurus. First of all, their nasal horn was very large and very long. Generally, the nasal horns of Spinops specimens were hooked backward. Like Centrosaurus, they had two small pyramid-like structures above their eyes. Spinops had ornaments very similar to those of Centrosaurus, above the head frills. At a first glance, they were very similar, some were drooping and some upward, but in fact, there were some differences between them. The reason why Centrosaurus got the name was not because of the sharp horn on its nose, but because there were small sharp horns on their frills. The two innermost horns of Centrosaurus curved inward in a hook shape, and some even overlapped each other. However, Spinops had no such feature. Instead of having two horns in the middle, it had two very long structures that stuck out like bunny ears, which looked a bit like the horns of Ainiosaurus. Like Centrosaurus, they all had a pair of hook-like horns that curved downward. In Spinops, we can see the head frills of ceratopsians, and especially the head frills of Centrosaurines were very rich in changes. Next, let's take a look at the very famous Styracosaurus, with even more exaggerated changes on the head frills. The face of Styracosaurus was also similar to that of Centrosaurus, with typical features of Centrosaurines. First of all, they had large nasal horns, with no horn or small brow horns. And the spikes on the frills were striking, which had developed into long horns. They had 10 spikes on their head frills, that were most salient. The first pair was the two on the inside, like Centrosaurus or Spinops, both drooping down, but not as long as the first two genera, but more like small hooks. Also, it had 8 very exaggerated spikes, with the first pair being the longest. With the outer covered keratins, when they were alive, the 2 spikes could be close to a meter in length. Fossil specimens show that the 2 horns could reach 60 to 70 centimeters long. The others got smaller in turn, not only in length, but also the directions changed. The first pair was upward, the second inclined, the third like this, the fourth inclined downward, and then moving downward. There were relatively normal small horns. This is Styracosaurus. In addition to Styracosaurus, there was also a genus of dinosaurs, with very developed spikes on their head frill, that is, Protoceratops, which looked somewhat similar to the previously described Centrosaurines. They all had exaggerated horn-like structures on their head frill, but they didn't look the same as those of the previously mentioned two genera. Theirs were either hanging down, especially straight, or curved to the outside, which was not the case to Protoceratops. Protoceratops had a pair of horns that curved forward, but the direction was not the same. Like Triceratops, their horns grew upward from the head frill and curved forward, appearing to be a defensive structure. One thing made Protoceratops different from all the previously introduced Centrosaurines was that it had very developed brow horns. Unlike many Centrosaurines, it had brow horns protruded upward. And unlike other Centrosaurines, they had no nasal horn. We know that Centrosaurines had very large nasal horns, while Protoceratops' nasal horn had degenerated very short, leaving only a keratinous structure. Protoceratops was small, so these horns might be used as a protection. Unlike ceratopsians, which were normally 5 or 6 meters long, Protoceratops were only about 3 meters long, and they were about the same size as the cattle we raise today. Let's move on to the next one.